Biomaterial Innovation Lab, as the name says, we are going to innovate solutions. But for why? Look at the picture, the smile. We want to improve the quality of life of whatever we innovate. It has to have a meaning in life, right? We were so fortunate that SprintRay, or the company, invested in us. We were able to hire a lot of top-notch talents. When we start the formulation, sometimes we develop up to 100 different formulations, and we print, we test, right, to have a leading candidate. And then after we have a leading candidate, we send it through the external testing and validations to make sure what we deliver to you guys are the top-notch product. Sometimes it takes up to 2 years, right? From the inception of an idea all the way to formulation, verification, validation, regulatory, manufacturing, right? It is not an easy process, but definitely it's very fun. A lot of materials off the shelf that we purchase, you cannot use in dental field because at the end of the day, the product has to be biocompatible. So in a day-to-day basis, in order for us to innovate, we have to look at all these dimensions and figure out the most optimum values to define the product. Late 2022, we developed a platform technology that we had inventions in both chemistry and the fillers, right? So the combination of these two inventions, it gave us the NanoFusion. What is NanoFusion? I mentioned we have fillers, which engineer those fillers. We work on the size, shape, form, surface of those fillers so that when they're blended into your polymer, it's like it dissolve or fuse into it, right? They don't agglomerate like the picture to the left. No one wants the material with the picture to the left. You always want to have a uniformly distributed fillers in your matrix that you're able to actually make a part that lasts the longest, right? The effective temperature is extremely important. In NanoFusion, I mentioned to you guys as we invent chemistry, right? So at body temperature, at this picture is around 37 C. But often you drink hot liquids, tea, water, right? Look at the NanoFusion. Basically, the invention that we have with the chemistry, it helps us retain the properties at high temperatures. We had a hot bath, right? We print 2 bars. We put weights on it. We raise the temperature to body temperature, which is 37 degrees C, and we let it sit. We monitor the deformation. When we do the innovation, we actually test what matters in dental. Strength, wear, toughness, stain, accuracy, shade. These are all important to you guys because you guys want to deliver the best and the best products to your patients, right? This is Apex resin. Look how natural and beautiful it is. You're very proud of the Apex material. It gives you the performance that you want. It gives you the translucency that you want. For the denture, for instance, you need to have a right strength. But often you don't need a strength at room temperature because people have it on. You really need to measure strength in water at the body environment, right? Take a moment to look at the Apex strength, flexural strength, for instance, and compare it with the traditional materials. It exceeds the traditional materials, right? And look at the 2 competitors that we had. These are the side-by-side comparison. The wear basically tells you the lifetime of your product. You don't want the product to lose weight, to lose volume, right? So the less, the better. Now look at the full arch. Another product came out of the NanoFusion. For the full arch, fracture toughness is extremely important, right? If you use the micron-sized particles, often what happens is, if you consider the notch is the hole in your full arch, the crack can pass through without any resistance, right? To the right side is a NanoFusion with the similar amount of fillers, but very small one, and we surface engineer so it blends into your matrix. What happens is the crack has to go and pass through all these small particles. Look at the fracture toughness, or K1C. And to the left is Onyx Tough. We have lithium disilicate and some PMMA. This is the 3D printing materials. We already surpassed the traditional materials and also enamel and dentin. What's important for most of you is the shade. We spend a lot of times in R&D to match the shade. Look at the Onyx. I remember for the bleach, to get to the bleach or A1, we actually had over 56, 57 iteration to get to the right shade. So we spend time to make sure what you get is exactly what the standard asks you. Now the translucency. You want to have a natural look, so you do want to have translucency, right? NanoFusion. These nano-sized particles was fused into your matrix. What happened to the left is if you have a large particles, right, when the light shines, they start scattering the light. Therefore, the part is not translucent. In NanoFusion, These small particles doesn't scatter the light, so you get the translucency that you would desire. Look at the left one, which was micron size, and look at the right one, which is the NanoFusion. Look at another picture, the process of the denture, right? This is one experimental materials that I'm showing you guys. It has over 50% ceramics in it. Over 50%. Look at the translucency of the product. It's a veneer. One of our doctors worked with us to print it, and this is what's possible.